Welcome back. So, during our last lecture, we were talking about different landforms on this particular image, and as we discussed in the beginning, that one can use the satellite data to identify different rock types as well as the landforms which we see on the surface. Okay. So, as I discussed in great details that this whole area which has a very diverse landforms is one of the most important to know the different environment. Okay. So, here in this satellite data, particularly the Landsat data which we are looking at right now, is a false color composite data which shows many different landscape, okay, which belongs to different environment. One is what we discussed in the north, okay, is your Thar desert here, and this marks the boundary between the desert and a marshy land. Okay. So, research which people have done in this area, based on that, people have talked about that this whole portion, okay, which you see from here, this boundary and goes down, is an indicative of ancient delta complex. Okay. Now, this I would relate it with very much similar to what we are having, see Sundarban delta in Bengal area, okay, in northeast India. So, this particular area is termed as the Palio delta complex. I am not going to get into the detail of the research which has been done on this, but yes, of course, the research groups have talked about that this there was there were mighty rivers which used to flow into this region particularly, okay, which was a part of then existing Arabian Sea. Okay. So, this was in shallow inlet of the sea, and if I go into little more detail about the Kutch, okay, in particularly the landscape of Kutch, and then Kutch itself in Gujarati is termed as Kajba. Kajba is like the tortoise, okay, and which used to remain covered or encircled by sea. But now there is no sea there, only the eastern the western portion is having the sea, but the area which used to be inundated or remained under the shallow sea inlet was this your delta complex, okay, and where you see now the great run of Kutch, which is completely and salt encrusted area. Okay. And if you look at this location, that is in Dholavira, which used to be the one of the largest settlement, okay, of Harappans. Okay. So, now if you consider that this landscape which exists now absolutely cannot favor the settlement in this area, but in the past, as Harappans were mostly they used the way of moving from one place to another place. Transportation was through navigation, and so water bodies definitely were there at that time. Okay. The another important part which I would like to highlight here is that if you make a note here, okay, what you have is an very dark patch, of course, as the reflectance is different than the surrounding area, and this is a small pond. Now, this pond is having getting the feed from this channel, which still exists, and this was the Shatadru channel or the Nara channel, which used to flow through this across this landform and then getting into the Kori Creek. Okay. But now it is not, because of the upliftment of this landform along this fault plane, okay, or the fault line, that is Alaband. So this happened as per the information or the historical chronicles. What it says that this landform got uplifted into 1819, and that was the event of Alaband. But our research suggests that probably there were more events which happened in the past, but the 1819 was the event which finally blocked this river channel and did not allow it to flow through this area. Okay. So now this exists as a small pond here, where the stream comes and getting debauched into this area. Okay. So if you consider this, that if this is blocked, then definitely this area is up and this is down here. Okay. So this also helps us in understanding that, okay, what could be the landscape in this area. Okay. So, and if you see the ground photograph of this pond, it is somewhere here like this. Okay. So you see the pond and very huge area, okay, which has been covered by this. Okay. Now moving further, this again and Landsat data with the different bands, which also helps us in identifying the clear landforms, okay, which we can demarcate easily. Okay, fine. So these are all, like here if you see, these are all igneous and igneous rocks, and on the periphery you see all tertiary rocks, and here also you are having this mainly the sandstone bodies and all that. Okay, fine. And as in form of the landforms, if you pick up, these are all small islands which you can outline or extract from this data. And then, as I was talking about, here is a pond, very small pond, and it's connected through this channel. Okay, so this channel is feeding this pond here, but it doesn't allow the channel to flow across this raised landform. And here we are having the boundary between the Thar desert and the marshy land here. Okay, fine. And the creek area which I was talking about, the Kori Creek, you can see on this. Okay. So this is another way to enhance the image and try to see and identify different landforms and do the terrain evaluation. Okay. Now coming the other part of the lithological analysis, mostly what we look at the outcrops or the landscape, okay, of various kind, and the subsurface, either it is we see rock, or maybe we come across the soil or loose material or alluvium. Okay. So the outcrop of various kinds of rocks that have been exposed through weathering and erosion can tell us great in detail about the composition of the rock units and their strike and depth relationship. This is a part of the structural part, but also it talks about, so what basically we will be able to gather is, one is the structural part here, and another is the composition to some extent. Okay, fine. This can be done using the land satellite photographs. Now depending on the climate, again, many of these lithological relationships are hidden, so you will not be able to see the clear-cut landforms which reflect the typical type of rocks or the environment, because they are hidden under the soil and thick vegetation. Okay. So this of course the limitation, okay, towards the identification. Okay. Hence it makes a bit difficult to identify the landforms or the subsurface features, okay, or the lithology, we can say. The photo interpretation basically we use as a combination of topographic expression, drainage pattern, texture, the tone of residual soil, structural imprint, these are the geological structures, and zoning pattern of natural vegetation. So these are few very important points or the parameters which you will take into consideration, okay, mainly the topography, okay, because not all areas which are having different type of rocks or the environment will have similar topography. Okay. some areas you will have very flat terrain, some areas you will have an typical hilly terrains. Okay, so that will also tell you about the environment of that particular area. Plus, as I have been emphasizing since long, that drainage pattern also reflects the subsurface lithology mainly. Okay, and along with that, the structural elements. Okay, what we are talking about, the either the area is folded or either the area is jointed. Okay, that will also tell us to some extent about the terrain. Okay, and it has been seen that not all the areas on the Earth's surface will have similar vegetation. It will vary from place to place. It will vary from different terrain to from one terrain to another terrain. Okay, so these are the important points which you should keep in mind while doing the photo interpretations. Okay, for example, flat-lying sedimentary rocks, okay, usually are seen because sedimentary rocks are so widely distributed, they composes the principal lithological feature seen on aerial photographs. Okay, coming to another part, that is the sedimentary rock, sandstone, which we usually come across. Okay, sandstone often provides one of the most weather resistance of the sedimentary rocks. Okay, they form a water source because they are porous in nature and display a typical pattern of drainage, which we term as an dendritic pattern. Okay, if not heavily jointed, okay, then you will be able to see the dendritic pattern, and if it is they are heavily jointed or fractured, then you won't be able to see a typical drainage, which we term as a dendritic pattern. Okay, they commonly appear as light tone, okay, on photochromatic photos because of the characteristic development of thin mantle of sand. Okay, so thin cover of sand usually will give you a very bright tone as compared to the other rocks. Okay, now in comparison to that, so we have shale. Okay, often forms landform lowlands. Okay, mainly lowlands because of a tendency for poor cementation and due to the inability of water to penetrate, okay, through it, making the constant runoff of precipitation and thus rapid erosion. Okay. So, in terms of the sandstone, what we learned was that it is a porous rock, okay, whereas this is not porous. Okay, right. So, this will result into closely spaced dendritic streams, okay, or the pattern as compared to the sandstone. So, sandstone will have slightly widely spaced streams, okay, or the drainage pattern, but this will have very closely spaced drainage pattern. Its photographic tone are mottled due to variation in moisture, but are often darker than the sandstones. Okay. Consider this two most commonly seen or encountered rocks in sedimentary environment. Okay, then you can easily make out the difference between these two. Okay, now let's see the how it looks like on photographs. Okay, as we discussed, one will be having is the sandstone is porous, whereas the shale is not so much porous as compared to the sandstone. Okay, sandstone will appear brighter, shale will appear darker. Okay, sandstone will have widely spaced drainage, will have close spaced drainage. Okay, because of it's not allowing the water to penetrate or percolate down and allowing the constant erosion. Okay, so this is the on your right is your shale and on your left is your sandstone. Okay, so you can easily make out at least look into this 2 photographs or similar type of photographs to identify the subsurface lithology. Okay. You can see the drainages are widely spaced, where here the drainages are very closely spaced, very fine drainage. Okay. Whereas this we say very coarse drainage. Okay. So these are the 2 very good examples which can straight away tell you about the subsurface lithology. Now here what we have done, we have simply used the drainage pattern as one of the criteria to identify the different land lithology. Now if we look at the further details of sandstone and shale, okay, what we need to keep in mind while identifying the sandstone terrain, okay, or the terrain which is composed of sandstone. Okay. Now we have several parameters here which we can keep in mind, and there is the one is the spectral characteristics. So we are not going to get into the detail, but I feel this is important because we see some tonal variations and use the tonal variation to identify different rocks. Okay. Now for example, weathering, if you take the sandstone are resistant to weathering, and in mostly if you look at either it is in humid terrain or in the dry regions. Okay. And in terms of the landforms which will be formed because of the erosion in the sandstone terrain will be like hills, ridges and scarps. Drainages what will be reflected on the surface will be low to medium density, and that is due to good porosity and permeability, because water, it will not allow water to flow over it. Okay. So runoff will be very less, and it has a tendency to show rectangular or angular drainage pattern, and that may be due to the joints which are present. Okay. So jointed terrain will have rectangular and angular drainage pattern. Okay. Dendritic stream pattern if not heavily jointed. Okay. So unless and until if you are not having very fractured rocks or the sandstone terrain, then you will come across the dendritic pattern. Vegetation good if soil cover, barren if poor. Okay. So there is no like in dry regions you will see and barren landscape where you are having sandstone. Okay. Now spectral characteristics, as I told in the previous slide also, they are light toned. Okay. Darker due to low emissibility and high topographic locations. Okay. So in some places you may come across the darker tones, and that will be because of the low emissibility and higher topographic locations. Overall response may be variable depending upon the surrounding rocks and soil, etc. Okay. So as we start that we can have multiple parameters which can help us in identifying. So if one doesn't work, then we can activate the another one to identify the lithological variation. Now these details are given below. You can refer to yes, okay, and then near infrared or shortwave infrared and all that. Okay. So the details are given here. So moving further, like what we have, the second one is shale. Okay. Now in terms of the weathering, it's incompetent, easily eroded. Okay. In terms of the landforms, low grounds and valleys, gently rounded. Okay. Hills in humid climate because of the erosion is more, okay, or intense, and erosion more intense in arid and to subarid regions. Okay. So you can have low grounds with rounded hills. Okay. Drainage density will be higher as compared to the sandstone, and that is due to its impervious nature. Okay. And the drainage pattern you will see dendritic, fine, long gullies, and what we say badland topography. Okay. As you have seen in the previous slides, I can refer that. Okay. Vegetation poor to barren in arid region, good in humid areas. Okay. And then further other details are been given here which you can refer. Okay, fine. So shales usually in dry bare shale appears slightly lighter tone. Okay. Otherwise, usually if it is rich or enriched with water, okay, if it is wet, then you will be able to see a very dark tone. Okay, fine. So this also can helps you in identifying. Now, if you say that no, that the you said that the sandstone is light tone, but then you can look at the drainage. Okay, the high density drainage density will be seen in terms of the shale. So that what I would like to emphasize, that you can use different parameters to identify the terrain very carefully. Okay, moving further, okay, in terms of the limestone, okay, or the dolomites. Okay, now limestone plains may contain little surface drainage, okay, due to the ability of subsurface or this of the ability of surface water to move underground. Okay, so it will move underground through sinkholes and underground caves in the limestone. Okay, so this is typical of a limestone terrain. Limestone terrain, you will have very poor drainage, okay, on the surface, and mostly you will see a karst topography, which usually we look at that it will have lot of potholes, okay, or we can say sinkholes in that. Okay, because the subsurface dissolution activity will not allow the water to flow on the surface, but it usually flows subsurface and it keep eroding. Okay, so the caves, formation of the caves underground is basically related to your subsurface dissolution activity. Okay, so in terms of the limestone weathering part, if you take, highly susceptible to dissolution by water, resistant in arid regions, and the topography which we see is termed as karst topography. Okay, subsidence and collapse structures are very common in such areas. Okay, and it will show a formation of sinkholes. Okay, in humid areas, ridges and hills in arid areas, sinking creeks, etc. in the coastal regions feature often elongated in the direction of prominent joints. Okay, so these are one of the most common topographic features which you will see in a limestone terrain. Okay, then in terms of the drainage, low drainage density in both arid and humid regions. Okay, dense in humid area, the vegetation, and sparse in karst topography of landforms. Okay, so this is an example of limestone where you can see the typical collapsed structures, sinkholes, dissolution gullies. Okay, so and then to some extent you can see the very linear joints, okay, which exist on the surface. So again, the drainage which you see is highly irregular here. You will not irregular in the sense, and sometimes you see the drainage exist, and then further you will not be able to trace out the drainage. Okay, so this is again and very typical of the limestone terrain. So this photograph shows a typical gullies, and then you have irregular drainages as well as the linear joints or the fractures which runs very straight. Okay, another photograph, as I was talking about, that you can easily make out if you are having the subsurface limestone terrain. Of course, the drainage is extremely poor here, but we see in very small dark patches here. These are all sinkholes, typical of the karst topography. Okay, now such areas should not be used for constructing a lifeline structures. Okay, and even if you are going to have the construction, should be ready to face the consequences that in future you may come across the collapses. Okay, so these are typical of the potholes. So very subdued topography you will be able to see, okay, with rounded hills and ranges, okay, in a limestone terrain. And as I told, that you should be ready to face such type of subsidence, sudden subsidence, or the collapse, because the subsurface erosion is continuous, okay, and you may come across, because in typical of the development of the sinkhole. Now this big sinkhole which you see here, you can make out the size based on the motor cars which are sitting here, okay, fine. So a very huge sinkhole which was been developed, okay, because of the subsurface erosion in a limestone terrain. Okay. Now stop here, and we will continue in the next lecture, okay.